Dear students, welcome to the knowledge series. We will have a discussion on compositions of classical and fuzzy relations. As you all know that the concept of fuzzy set is a generalization of crisp set, and we have discussed a lot about this one in the previous and earlier video series. Now the relations between the crisp set can be extended to the fuzzy relations, and the relations will be considered as a fuzzy set, that you all aware about it. Now based on the further discussions, there is a term called a compositions. Now the operation executed in a two compatible fuzzy relations to get a single fuzzy relation is called a fuzzy compositions. That means you are trying to take the fuzzy relations and from the fuzzy relation you're mapping with another fuzzy relations so that you can compose it. So from the set you try to create a fuzzy relations. In the previous video series you have gone through it, and now we are going to discuss fuzzy based on collection of fuzzy relations and try to do an operation to execute it. That is what termed as a compositions. Now in the crisp relations we represent between the presence and absence of the set elements in terms of interaction, associations, connection. That's how we try to discuss the crisp relation, and there we try to produce the Cartesian products also. Similarly, we also try to see the fuzzy Cartesian product with respect to the element and the membership value. Now in the compositions there is something it has to discuss with respect to minimum maximum terms. That is the speciality in the case of a compositions. Now here when we try to see the composition of a classical relation, it is mentioned that the operation executed by a two compatible binary relations to get a single binary. That means two fuzzy relation to get a single fuzzy. That is called as a compositions. Now the relation R is a relations between x and y. So that means x and y is a universe of discourse, but of course that x itself is having relations and y is also having some relations. So between relation to relations we try to find out another relations R. Similarly yes between let us take a y and z. So y is one relations, z is another relation. From there too we try to find out a new relation s. Then we try to create another relations which is the relations between the R and S. That R and S is represent in this notation R a circle of S. That is called as a compositions, or we put it as R like a dot but bigger in size. So that is known as RS of two relations R and S. So the compositions R dot S is equal to RS of the two relations R and S express the relations between the X and Z. That is what. Now to understand this one, let us go refer to this statement also. The two binary relation R and S relations are compatible if R is a subset of X and cross Y. That means between X is a separate universe of a discourse where you are having a relations. Y is a separate universe of discourse where you are having a separate relations. Now these two relations, from there you are creating R. So R is a subset of X cross Y. Now similarly S is having a Y universe of a discourse where the separate set of elements are having a relations. Z is another universe of a discourse with a set of elements. C is having a relation. So these two relations you are mapping in such a way that the S relation S you are generating, that S is nothing but a subset of a Y cross Z. Now with these two separate relations, you are trying to find out a common relation. So R composition S is a relation of X cos Z. So when you take these two relations, then it is the relation between X and Z. So where Y is hidden relations. So R cross Z, that is equal to that equal to T. That is the T is the composition. The composition T is nothing but R compositions S is equal to X comma Z, such that XY belongs to R, YZ belongs to S. So this is what we represent, and for all Y belongs to Y. That means this is the hidden elements where all the Y is belongs to Y, whereas Y is here also, Y is here also. Now if you go further, you will find that it talks about a minimum operations taking place between XY and YZ membership values, and on the top of it you are doing a maximum. I repeat again, this the compositions R and S, if you represent in terms of a membership values, mu R of S, that is equal to it, the whole representations is going to become like a minimum membership value of these two, comma minimum membership value of these two, and within that two membership you are taking that taking into consideration, and the top of it you are doing a maximum of these two membership value. So maximum of minimum value of this membership and minimum value of this one. That is a compositions is being put into considerations when you are doing a inner product. So if you try to see under this particular condition of a representation, and if you see this particular figure, what exactly this figure represent? This figure represent that it's look like a sagittal diagram, but not a sagittal diagram. It is a bipartite graph. So that is how you try to see across this particular relations. So under the bipartite graph, so you have seen that a set of element is being mapped, and R X cross Y you are defined with respect to whichever is the arrow is interacting the 2 points, like A1 B1 A1 B1 A1 B2 A2 B2 A3 B3. So you will be having 4 values, that is what, whereas here you will be finding 3 values, B1 C1 B2 C3 and B3 C2, that 3 values. So that is how you represent these relations. Now if you try to create the compositions, then you have to take a relation R and S together. So that is what you are written. The composite relations is nothing but T is equal to R composite Z, where you will take into considerations these values. Wherever the arrow starts from A and reaches to the C, that one you are taking. A1 to B1 to C1, A2 to A1 to B2 to C3, A3 to B3 to C3, this and A2 to B2 to C3. So this is what we are going to say, and A1 to B2 to C3. That is how we are representing. Now, when you try to see in this case, you will be having 4 values: 1 value, 2 value, 3 value, and 4 value. That is what you have seeing here, our composition say. Now further, if you want to represent this one in the matrix forms, so if you are taking only R1, so you have A1 A2 A3 one side, B1 B2 B3 one side, and if you try to see that, if you put it A1 B1, so in that case A1 B1 is equal to 1, A1 B1 is 1, then A2 B2 is equal to 1, then A3 B3 is equal to 1. So that is what we try to see. Similarly, S also we try to create B1 B2 B3 and C1 C2 C3, and corresponding to that one, B1 C1 is equal to 1, your B2 C3 is equal to 1, and B3 C2 is equal to 1. That's how we represent this one. And when you try to represent T is the relations between A1 A2 A3 and C1 C2 C3. This B1 B2 B3 is hidden, so that is what been shown over here. So you are having A1 C1, so A1 C1 is 1. Similarly, all other and A1 C3, I am putting A1 C3 is equal to, like that you feel it, this 4 element is coming here, and that's how we represent the matrix. Now this theory is a very important theory, dear students. You have to understand that it appears in almost all the university exams. So based on these discussions, we go further and we try to see the another point of discussions with respect to the compositions operations. When we take into consideration the compositions operations, you have to understand this compositions operation. It represents in terms of two conditions. That means that composition operations based on two types in a CRISP: maximum minimum composition and maximum product compositions. Now this maximum minimum product compositions is it is an interesting operations, and to understand this particular operations, if you try to look across this chain of systems, in the bottom side I have shown a chain where if you when you pull this chain, there are 3 different level of chain chain is being put, where the chain beats are pulled, but when you try to pull this beats, the one which is having a long length, it will be loose, but the other bead will be tightened. So that is the analogy of understanding this one is that when you pull the this chain from the either side by tensile force, it will all the chain try to be in aligned, and when you that is known as maximum and minimum. And when you try to twist this one, then it is known as a maximum product terms. All will be aligned in a one direction, so that is known as a maximum, and one is having a maximum and inside one is a minimum. And when you try to rotate it, the one which is having a long, that is a maximum, and others along with that the others are twisted, so that is known as a maximum product compositions. So maximum minimum compositions, when we try to look into, is the strongest the beads chain that will be having a maximum strength in these systems. So that is what mean to say the maximum strength depends upon the maximum value of that particular length of the beads, or the particular relations which is having a maximum values. So if you take a maximum minimum compositions in a theoretical way, that T is equal to R composition S, where R is having a relation X and Y, and X is having a relation Y and Z. So OR operation we define in terms of like a V, and inverted V is a minimum operations. So this is maximum, this is a minimum. OR is a max. OR is defined with respect to V and is defined with respect to inverted V. So chi of X comma Z defined as that is a OR operation, maximum operation of Y belongs to Y, that is among this one Y is the common. So chi of R, relation R of X, Y, it's AND operations of chi of X, S, Y comma Z. So that is how we try to represent this one. So when we try to represent this X comma Z, the psi of X comma Y is nothing but common relations, and chi of X comma S is nothing but Y comma Z, that is the relations, common relation between Y and Z. So among these two relations we try to take the minimum values. So that is what we termed as a minimum values. Now once we find the minimum value, its maximum value we are taking from the x. That is known as a maximum minimum composition. That means x and y and z, its minimum, and when we take together, then it's externally, that is known as a maximum. So this is maximum, these two are the minimum compositions. Now maximum product compositions, here what is that, it is exactly like this, only the difference is that this logical operation is represented by the dot. So that is a product, that is here it comes as a product, and here the external is a maximum product. So this is what we talk with respect to the maximum, the chain length analogy of a maximum minimum compositions. How we the chain of beads is being pulled from the either side, so that overall chain strength is being represented as a maximum operation or a maximum minimum operations or maximum product operations. To understand this logic in terms of a numerical problem, you try to see this one. Here we taken a values x1, x2, x3 in terms of a crisp value, y1, y2, 3, a crisp value is taken, and of r between x and y, and s is taken y1, y2, y3, x1, s2 with respect to a crisp value, and from this we have to find the compositions. That is a maximum minimum compositions, how we are going to find. This is a very important question which normally appears in the university papers. So here, if you want to find out, we write xt, x1, z1. See, when we are doing this one, you have to remember like this. This is x1 and y1, and next is y1 and z1. So this y1 and y1 is a silent. You neglect these values. So if you are taking a these two matrix and trying to take a relation, say minimum relations, what you find, x1, you forget about this one, x1, and you are taking in this particular case x1, z1. So x1 and z1, when you are trying to see, so how will you do? You take this row and this column. That means x1 row and z1 column. You forget about this y1 timing, because if you are focusing on the y1, it will be getting confused. So you remember that this element, each element of this row, you are making a relations with each element of this column, and then you are taking its minimum value. So y1 with this one 0. So that is what a minimum operation of 1 and 0. Then this one with the second one, that is what. Then third one with this third one, that is what. Then the fourth one is with this fourth one. That is what represented here. So when you try to see here, the minimum is 0, 0, 0, 0. And what is the maximum of all 0? It is 0. That is what. Similarly, x2. X2 is taken from this row and this particular column. This particular column. Now, when we try to see x1, this relations x1 with z2. Already this is over with the second row. Now 1 with this, then 0 with this, 1 with this, 0 with this. Now this row and this column, its minimum operation we have written here, and its minimum is here is 1, 0, 1, 0. And what its maximum? All these values, it becomes 1, because this is 1, 0, 1, 0. Among these 4 elements relations, you have a maximum value is equal to 1. So you have got for x1. Now similarly x2 you do with this column, then this x2 with this column. Similarly x3 with this column, x3 with this column. Like that, if you try to create, you will be finding the various value, and finally when you try to write the relations between our composition x, that is x1, x2, x3, this one, here this one will not be there, only Z1 and Z2 you have to write. These three elements on the vertical lines, and this Z1 Z2 on the horizontal line, and that is in the x-axis, and this is y-axis. That is what I mean to say. In the matrix form, where you know that x1 z1, in first case it was 0, that was seen. Then x1 z2 you got it as 1. Similarly, when you follow with others, you find it. This same logic you apply for the maximum product compositions. That means you take this one and you product with this particular case. So that is what been shown, x1 z1. In x1 z1 case, what it is a state product. 1 into 0 is 0. So that is what you have seen. All are becoming 0, and it's that is the product. This is a product. This is not a minimum. This is a product. Its maximum value is what? 0. So that's how we are going to see. You will be finding these values. So this is known as the maximum minimum maximum product compositions. Now coming to the properties, there are certain properties. R composition S compositions Y is same equal to R compositions S composition M. So that means here there are not only two relations, there is a third relations also. That is what been shown here. This is known as a compositions. Composition of only two relations. Here a composition with one more relation is been shown. Now commutative means R composition S is not same as S compositions R. Inverse R composition of S inverse is S inverse compositions are inverse. So these are the certain things. Now here what we talked about the maximum minimum compositions in the previous point, it has been rewritten in the form of a theoretical way of writing the functions. That is R, S, and its composition T, X, Z. That is been represent the maximum of the overall minimum of mu R of xy, mu of yz. Similarly, for maximum product and minimum compositions and maximum average compositions, that's how this entire thing is being put across. Now, if you come across a numerical problem here with respect to the maximum, minimum, maximum product, maximum average, minimum, maximum compositions of these relations. If you try to see maximum, minimum compositions, as we have seen in the case R compositions S. What is the R composition S? So we have to write, there is a R relation is being given in the question paper. S relation is shown like this one. This is 2 by 2 matrix, here 2 by 3 matrix. That is how it has been shown. So based on that, you have to find the R composition. How will you do? You take first row of R and first row first column of S. Then you try to take the minimum value 0.7, 0.9, 0.7, 0.5, 0.1. It is 0.1. And what is the maximum of these two value? It is 0.7. That is what here. Like that you carry out here. Similarly, the maximum product compositions. Also, you follow in that same way. You do the product compositions. You try to see here 0.7 into 0.5, 0.7 into here it is 0.7 into 0.9, that is 0.63, 0.5 into 0.1, 0.05. Among this particular case, what is the maximum? It is 0.063. There is a this is error. You just ignore it. This is 0.63. Among these two, which is the value? 0.6. That is what you try here. So this is how you do. Average, what you do? You do the average. You do after finding the summations, you take the two values. That means you sum these two values, 0.7 plus 0.9 divided by 2. Like that, you carry out and do all the calculation for the all the sections. That is known as maximum average. Minimum, maximum composition. Minimum, maximum of composition is the reverse of maximum, minimum compositions. That means you do the first the maximum inside, and externally you do the minimum. That is known as a maximum, minimum compositions. So these particular problems definitely it gives an idea with respect to the logic. and this is the properties as I have explained, shown to you, explained to you in the previous slides. Now here there are some more examples. This example is also straightforward with respect to that we have seen in the previous discussions with respect to the compositions on the fruits, where we talk about the only fruits with respect to fruits, and you remember that with respect to fruits and the fever that I have explained in my previous video series about how we defines the fruits with respect to the fuzzy or a crisp value. Similarly, here we are having fruits with respect to the color and its states, and also its taste, its state and its taste. Here color and state, here state and taste. So among this one you have to find the maximum minimum product. It is a straightforward. You have a green, red, yellow one point, and another sour, sweet, and sweet, sour, and sweet. And this unripe, semi-ripe, ripe, this will be hidden. So you will be finally, when you do it, you will be getting this way, the color versus the taste conditions. So you will getting the similar value. This is very straightforward. Everything is self-explanatory. It is being given, and you will be seeing that it's a maximum minimum compositions. First you do the internal minimum value element to element, and then on the top you do the maximum. That will give the end results. Similarly, the maximum minimum compositions you go maximum product composition, you do the product compositions of each element, and after doing that one you do the maximum value. Similarly, you follow for the individual points and try to fill these sections. So that's how this particular example gives, even if it is appearing like a certain statement, but it is easy to solve. Now here is a two relation in a different product space can be correlated with each other by means of compositions. That means you are having a two space, under the two space you are trying to make the take that relations, that two space relations, and then you are going to compose it. That is known as compositions. As the relations are the fuzzy set, so the compositions of relations is also fuzzy set. That's a straightforward. Finally, let me conclude with the cardinality of fuzzy relations. This is a normally asked question in what is the cardinality of fuzzy relations. Now here given a statement, cardinality of a crisp set is the number of element in the set. Using a fuzzy set which are many valued relations, because in the cardinality when we talk about any set is nothing but number of element in that set or number of states in that set. In the crisp set there are two states, 0 and 1. So our cardinality is 2. Now when you talk about a fuzzy set, our range between 0 to 1. So in that case you are having a infinite values. So that is how the fuzzy relation is being defined. So what is the cardinality of a fuzzy relations? When you talk about a cardinality of a fuzzy relation, again it comes from between the range value, because if you take this is a one fuzzy set, it has a range 0 to 1. So all the element from a 0 to 1 is infinite value. Similarly, another fuzzy set is also having an infinite value 0 to 1. So if you want to take a relations from for this edge between A and B, or this edge between A and B, you know that if this is infinite and this is infinite, your composition is also going to be infinite. So that is what the cardinality of a fuzzy set on any universe of U is infinite. Hence the cardinality of fuzzy relation between the two or more universe of discourse is also infinite. Now here given, refer to the two set A and B with the condition 0 less than mu A cross B xy. That is what it is being shown over here. If this is a relation, this is a relation, and if you put it as a dot, it become a composition less than equal to 1, where mapping of inclined region has infinite value of relation. This results of the occurrence of partial membership in the fuzzy set and a fuzzy relation. So that's how the cardinality also shows the infinite value. So with this I conclude the discussions with respect to compositions.